And good morning, ladies and gents. I did grade these tests, well, the mid-chapter test, the quizzes, and I wanted to get those back to you, so you should have received some scores and check real time. You can see your scores, but I did know some of you want to find solutions to some issues, so here we go. All right, so longest chord in a circle, longest chord, as you stretch it all the way across, you got one right here, diameter. All right, so that was good, so that's going to be an A for this guy. For number 2, if the radius is 4 centimeters, right? So remember, this is 4. This thing's a pain to draw with. So these are both 4. And you have to also find the radius for the bigger circle. If it's 20 pi, remember radius, your circumference formula is 2 pi r. So that's twice the radius right there. So this is 10, right? And this is 10. Add them up, 10, 10, 20, 8, right? So that's how you get J. All right, so moving on. Chord for angle P measured 8 inches, and the distance from the center of the chord is 3 inches. So remember, so this can be a horrible circle. All right, so if I've got that chord, I've got a chord, let's see, 8 inches. Oops, not that. Let me erase this guy. So if the chord itself is 3 inches, center of the chord is 3 inches. I have to make this a little bit bigger. So say your chord is over here. You've got your center. That's going to be 3. So if you got 3 here, the chord measures 8 inches. So you're actually going to have this piece over here is a 3. Each side here is going to be a 4. And then you want to find the radius of the circle. Look at that. Nice right triangle in there, 3, 4. And if you do Pythagorean theorem or remember the triples, that's got to be a 5. Right, so that's B. All right, so that's the first 3. Next one, MON is 86. So if this angle is 86, you know that this arc is also 86. So that's your central angle. But MPN is an inscribed angle, so that's half of 86, which, boom, 43. So that's H. So make sure, yeah, inscribed angle is half the arc, central angle equals the arc. Make sure you remember that. Okay, next one, number 5. So these two, remember, if you have two angles that share the same intercepted arc, these are equal. All right, so if I work these out, right, so you've got 2x plus 10. All right, so make that equal to the other side, which is 3x minus 6. I'll do the quick math because this thing is a pain to write with. So 3x minus 6. So remember, get your x's together. If I subtract x over here, then it's going to be an x on this side. And bring the 6 over back to the left, so you got 16. Right, so x is 16, so that's your B. Now these do get a little bit more complicated as you go further for part 2. So AE is a diameter, so you've got that. BGE is 136. So remember, if this angle is 136, this arc is 136, right? But angle AB, or sorry, arc AB is this other piece, and if you have a diameter, it's all 180. So take 180 and just subtract 36, and you're going to get, or sorry, subtract your 136. You're going to get 44. All right, so 44 is your angle, or your arc measure for this one, arc degrees, so 44. All right, next, number 7 through 10 here. So these ones, so circle with a radius of 12 inches, has an arc that measures 8 pi inches. Find the measure of the central angle determined by this arc. So remember, this goes back to that formula, the x over 360. Just start plugging things in here. This is the formula to find the length of the arc. X over 360 times 2 pi r. And you've got 2 pi, and you're given a radius. So your radius is 12. Right now, that's going to be equal to 8 pi. Right, so if I do that, now you've got the equation, we've got to solve it. The nice part is, as you start working these out, well, pi's are going to cancel. Right, 2 times 12 is 24, and you've got 8 here. So it's really 24x over 360 equals 8. Well, let me see if I can put that down below here. So if you've got 24, right, x over 360, right, equals 8. Then however you can start working through here, my mind goes right to, I can see some reducing in here to make your life a little bit easier. If not, you'd have to multiply by 360. So I can divide these both by 12. So it's really 2x over 30, right, is going to be equal to 8. You can even reduce this further, 1 over 15, but to get rid of that, you can multiply by that reciprocal, which is 30 over 2. And so this is really going to be 240 over 2, or 120. Right, so that's that answer. Right, so 7's 120. And it doesn't matter how you reduce, but reduce that to get down to your final answer of 120. All right, let me erase this so I get some room. Then number 8, let's see. So this, you've got two chords. Right, so the chords here are 4x minus 6 and 6x minus 12. And if they're both the same distance from the center, I'm going to have to drag this down here again as well. So if they're both the same distance from the center, the chords are the same length. So this is actually going to help to have a little picture. This is what I did on my paper here. I've got chord AB, which is this guy. And if I did CD over here, and I apologize for the drawing, this touchpad makes it look like a kindergartner's writing. But there's point P. So if they're both 4 from there, we're assuming right angles. So if that's a 4, right, so you're going to have to set these two equal. So if I've got 4x minus 6, right, equals 6x minus 12. And same thing we did before. So set them equal and solve it. And let's see, trying to just smush this in here. 6x minus 12. Again, same thing. If I bring my x's over, there's a 2x here. And the other side gives me 6. So I know that my x is 3. So if my x is 3, and I plug it back into either one of the chords, say I pick this one, right? 4 times 3, 12 minus 6 gives me 6. So each chord is a length of 6. So look, if that's 4, that's going to be 3. And then all of a sudden you can find AP, which it doesn't matter if it's this chord or this chord, they're all the same dimensions. AP is that radius basically. Hey, look, there's another radius. So all these radii are the same, so 3, 4, and then there's that 5. Right, so Pythagorean theorem, Pythag it up. Or if you remember those Pythagorean triples, that'll help you with that. Right, so that's that guy. Then, for number 9, the tablecloth. It's as simple as finding the Pythagorean theorem using whatever you have here. So it's a nice application problem, which, let me get rid of this guy too. So yeah, if you have your circle and you've got this tablecloth that goes across where all the corners lie on the circle, then if you simply find your diagonal, that's your diameter. Right? From diameter, you find your radius. So if it's 8 by 15, when you Pythag it up, you get 17 for this. And then 17 divided by 2 is 8.5. Okay, and then one last. And this one, I did have a bunch of common issues here. Be careful, ladies and gents, when you're solving problems like this. So inside this one, get my tool here. So you're finding angle ABC. So angle ABC is going to use this arc all the way over here, right? A lot of people were using this arc, which is 186 divided by 2, is not the answer. If it's 186, we have to subtract from 360. Right, so 360 minus 186 is going to give me 174. So that's what you have to divide by 2, because it is an inscribed angle. Whoa, 174. Right, so get rid of that. Oop, don't want to do that. So if I take 174 and then divide that by 2, you're going to get 87. And 87 degrees is the solution I'm looking for. Right, some people had 93, which would be the other side, right? This angle is 93 here. That's angle CDA. We want angle ABC, which is 87. Right, so there's your solutions. Hope this helps. Next week, we're going through more circle work. Really, we're going to finish up the chapter in the next 2 weeks. And at the end of that second week, we're looking at a chapter test. So please let me know if you have any questions on these, and have a good weekend. Thanks, guys. Bye.